All right. So welcome everyone. Thank you for your patience. My name is Caleb Powell, and I'm an environmental scientist for TDEC, which is the Tennessee Department of Environment and Conservation, Office of Sustainable Practices. This pollution prevention webinar is one of 4 that we have each year. We have quarterly webinars, and today we are going to specifically be talking about compressed air and cooling best practices. Now, whenever you think of that, well, for me, I know whenever I think of best practices, I think of the Best Practices magazine and the Best Practices Expo that goes on every year. If you haven't heard of that, that's who we're going to be hearing from today. We are going to be hearing from Rod Smith. He's actually the publisher of the Best Practices magazine, and they've specifically today we're going to be hearing about the compressed air and the cooling side of things. So without further ado, I'm going to pass it over to Rod, and then he's going to get started. So thanks everyone for joining. Also, if you have any questions, everyone's muted upon entry. Use that chat box down there to send to either like all the panelists or the host, just making sure that the host or my name is in that box so that you are able to get that question to me and I can ask that question to Rod. So without further ado, I'm going to pass it over to Rod, and I'm going to the first slide, Rod, so you can go talk a little bit about yourself and then we'll get into it.
Okay, thank you, Caleb. Can you hear me all right?
Yes, sir.
Okay, great. Well, you see my bio. I've been in compressed air a long time. Worked for 2 of the major air compressor products, American Compressed Air System Products manufacturers, and we founded the publication in 2006. And we're here to promote our show happening this year in October in Atlanta. I would like to invite you all to come down. We had a wonderful time in Nashville 2 years ago, or in 2019, I should say, and it was very well attended. And so, yeah, next slide.
All right.
Okay, I'm sorry. I forgot that I'm not looking at it. Okay, so basically we have some promotional slides here for the show. I'm going to go through quickly so we can get to the meat of the presentation, but we invite all of you to come to the show. There's a new technology. We say the 4 reasons to come to the expo. There's a new technology expo with on-the-floor classroom. Next slide. There's a keynote presentations that you can attend. So basically for $50, you can attend these 4 things. You can go to the keynote presentations, go to the expo, participate in the Expo $1,000 Energy Treasure Hunt raffle, and attend 2 catered networking events. We're teaching plants how to optimize compressed air, vacuum, and cooling systems, how to save energy, and how to have a more reliable and safe system. There are 2 conference tracks. One is dedicated to energy and water conservation, and the second track is dedicated to safety, reliability, for the maintenance teams. Okay, so anyways, check out your schedule, visit our website, cabpexpo.com, and we'd love to see you there down in Atlanta. Okay, can you take me down to the beginning of the presentation, slide 5, Caleb?
All right.
Thank you. So this presentation will give you a glimpse about compressed air energy conservation. It has some case studies, some examples from current and former editorial board members from PepsiCo, Archer Daniels, Saint-Gobain, Ball Corporation, Cal Portland. Next slide. This is a blurb about our magazine. I like to say I sell free magazines for a living. We'd love to invite all of you to subscribe to the magazine at airbestpractices.com. Get your team members signed up. The price is right. It's a free publication, and we're just trying to get those best practices taught out there to do what, to help TDEC out and save some energy in Tennessee. Next slide. So before we get into this, I like to say why bother with compressed air. And here's an example of some energy conservation projects that one company called HDE Technologies did just in Missouri area. 6 air compressors consuming 8 million kilowatt hours. An audit reduced this to 4.3 million kilowatt hours, $370,000 of savings per year. Air compressors are off the radar screen in most plants, and there are big energy savings in some of them. Another example, they produced 35 PSIG air with low pressure compressors, they put in low pressure compressors to replace 100 PSI compressors, eliminating 800 horsepower, energy savings of 7.5 million kilowatt hours, energy incentive of $500,000. Okay, that's the best practices. Are you using high pressure compressed air for low pressure applications? Okay, and smaller plants, you know, even a 50 horsepower compressor can save a nice amount of money, get a nice rebate from the local incentive. So this isn't just for big, huge manufacturing plants. It all adds up when it comes to the bottom line. Okay, next slide, please. So I'm going to show you examples of projects in this presentation. At the end of the day, though, you'll want to hire a compressed air specialist or an auditor to help you. This slide has got a lot to it, but this is what Archer Daniels Midland, this is their checklist of how to select a compressed air auditor. And they broke it down to 7 selection criteria, and they ended up choosing Brent Darnell, who is from the John Henry Foster Company. ADM, by the way, has what some people say is the biggest compressed air installation in the United States. So we think this is a great list of, you know, ask people to provide a sample report. If they start hemming and hawing, that's not good. Ask what are the deliverables after the audit? What will you get? A detailed report? Will you get raw data? Third, ensure they'll audit the whole system, not just the air compressors. That's very common. Yep, we'll do an audit, but then they only look at your air compressors. It's important to look on the demand side. So there are a few other things here that I thought was a nice list of things you could go through. Next slide, please. Okay, now we're in the meat of the presentation where I created this presentation saying, hey, for compressed air systems, let's figure out if you're in phase 1 or in phase 2. And this is something you could share with your staff. What is phase 1 best practices? You know, that's something I've made up, okay? But it's a way of saying how far along are we on our compressed air journey of optimizing it. It's a good way to check each plant that you have or your plant. So what I would consider a phase 1 is, do we really understand what we own, and do we have a box diagram of our compressed air system which is detailed, like this one here, right? Air compressor is the first box, after cooler. Do you have a zero air loss drain on it? Is it going to a drain manifold and then to an oil water separator? Then do you have a wet control tank? Does it have a zero air loss drain? Or is it a drain that's not functioning very well? Then air dryer. What kind of air dryer do we have? Does it have a zero air loss drain? Filter or filters. So this is what the Compressed Air Challenge teaches, is to create a box diagram of what you own. So you know what you own and you have a maintenance plan for it. Next slide. Data log your air compressors. Bring someone in. I know some energy managers that'll have learned how to data log air compressors themselves. It's an electric motor at the end of the day. But get an understanding of when are your air compressors working, what load are they running. Okay, that's a fundamental understanding that's important to know. Are they running flat out, or are they running flat out for 2 hours and then not running at 10% for 2 hours and then running flat out for 2 hours? What's the profile? So data log your air compressors. And then next slide, which is still data logging, that'll allow you to, together with an auditor, and they should do this for you if you don't have it, but this, again, this is what do you know about your system? You're going to need help to do this, but that can give you some key performance indicators, right? What is your average system flow? What's your average compressor discharge pressure? What's your average system pressure? Which the differential is your pressure drop, 10 pounds of pressure drop. It's a good system. What's your input electric power? How many hours are you running? And for me, every plant should have an understanding of what is your specific power. In this case, it's 5.12 CFM per kilowatt hour. Okay, that's a great key performance indicator I think every plant should have. How much electricity, how much airflow in CFM do I get per kilowatt? It's a great efficiency measure. Not a lot of plants have it. And then you can put the dollars you pay at your plant and get a number for your year. Okay, so then the third point of fundamental, the next slide, is optimize compressor controls. Okay, the first 2 points where you did a box diagram, you know what you own, then you data log them, so you established a baseline energy consumption. And now you want to optimize compressor controls. And the reason for that, if you look at this graph, is you don't want to go doing compressed air leak audits out there if your air compressors won't save energy. So depending, you know, if a compressed air leak audit is fantastic, it'll reduce flow requirements, but it won't save you energy. And they don't tell you that. It will not save you any energy on the air compressor unless you have the right type of compressor controls, right? The most commonly known being a variable speed drive compressor control. So this diagram shows an example of that where flow on the top line is changing, going up and down, while the kilowatts being used by the air compressors isn't changing. Okay, this is an example of a fixed speed air compressor. It doesn't matter what's going on with demand, it's still going to use the same amount of energy. Okay, so this is a critical part of understanding your system of optimizing controls. So next slide, please. So this is just an example going back to a box diagram, a little more detailed. Air compressors at the top, receiver tanks, a dryer, wet receiver tank, dry receiver tank. Okay, next slide. Another example of the kind of, I put these out here so you would have an example that you could provide your vendor. Hey, I'd like a box diagram like this. Hey, I'd like data logging example like this table here. Right, my air compressors are listed on the left. At full load, I'm getting a picture of, you know, they'll data log, they'll get all the squiggly lines, but they can bring it into a table. What is my kilowatts? What's my flow, et cetera, et cetera. Next slide, please. And lastly, you know, what are some of the key performance indicators that we can then get from that? Again, I put these here so that you can come back to them, show them to your vendor, people taking care of it, and said, hey, I'd like to have this data. And they're perfectly capable of providing it. Okay, next slide. This is what deliverable you could get on optimizing compressor controls. You go to your vendor, you say, hey, Mr. Compressed Air Expert, I want a table like this. What kind of controls do I have on my air compressors? You might have 6 of them with 6 different control types. What is their efficiency? Okay. All right, so that's phase 1. Now we'll go to phase 2. Phase 1, again, now you have a good understanding of what you own. You have an understanding of how much they're working. You've data logged them, and you have an understanding of what kind of controls you have on air compressors. The big thing being is, how efficient are they running? And if I use less compressed air, will that translate itself into savings? All right, so now phase 2 are examples. Next slide, it should say selecting the right compressed air solutions at the top, and phase 2, measure airflow. Are we together, Caleb?
Yes, sir. Yes, sir.
Okay, thank you. Hey, we're making it happen here. So, okay, this came from Saint-Gobain, and this was an example of, they had variable speed drive air compressors. They knew if they reduced flow, they would see energy savings. So they said, all right, we're going to put in flow meters. We're going to reduce the flow requirements of production equipment. And the way we're going to do that is by putting a bunch of flow meters, compressed air flow meters, that's what's pictured here. 6 of them on a panel, which are on the compressed air lines going to 6 different machines, okay? And so they were able to fix the leaks on the machines and establish a best practice flow for each machine. And they now monitor that flow. So when, it's not if, it's when a leak appears down the road because pneumatic hoses get brittle and whatnot, they'll get an alarm from the flow meter. So here's a close-up of the back side of the panel. Next slide, please, Caleb. You can just see the back slide. It's connected to a Hobo data logger, I think that is, but they're able to monitor it. Okay. Next slide. Okay, here's Honda of America. You see I've highlighted the second bullet point. It's a busy slide, but basically, once you're monitoring flow into production areas and you know how much compressed air goes into different areas, what Honda does, what I haven't highlighted, is you can start charging production areas for CFM consumption. Okay, you know what your cost of compressed air is. You might split it into half-half. I've got 2 main lines in my building. I'm going to split it 50-50. Or into those 2 areas, but now you're measuring flow with flow meters, you can charge them accordingly. Pictured is Mike here, rest in peace Mike, but on the left, he was on the maintenance of the CRV line, and he called me once some time ago and said he was excited because he had found a small leak. They had optimized their system so much he was excited to find 100 CFM in savings and wanted to show me where it was on the CRV production line. Honda's story was amazing with compressed air. They went from 5,450 horsepower in the late 90s, here in this phase 1, making 240,000 cars, to, in 2002, they were using 2,450. They took 3,000 horsepower offline, made the same amount of cars. Incredible system. Okay, next slide. Another great thing to do is shutdown optimization. Do you have machines that use compressed air that have open valves? There are a lot of machines out there, bottling machines, packaging machines that have pneumatic circuits on them with the valves always open. And when the machine is down, it's still using compressed air. So if you can go find those, shutdown optimization, if you can go find those valves, there are nice products on the market which will, with a timer, which will allow you to turn compressed air on and off if you have a predictive cycle for that machine. Maybe it's simply the overnight cycle. Here on this picture, it is something that came from Visteon. These are chemical tanks that have to have an airlock, and they noticed that overnight when the plant was down, the required airlock on these was causing a 100 horsepower compressor to turn on. So they just went and bought a little 5 horsepower hobby compressor to take care of the airlock and disconnected it from the compressed air system. And saw really nice savings on the 100 horsepower. So shutdown optimization is another phase 2 project. Another phase 2 project, heat recovery. Okay, there's a lot here, but as you know, or perhaps you don't, but 80 to 84 to 85% of the input power into an air compressor goes to heat. Only about 15% is converted into compressed air. So you can recover that heat into your HVAC system. You can also turn that heat with a heat exchanger into heated processed water. So it's a lot of plants have an opportunity for heat recovery. If you ask your compressed air vendor, they have standard heat recovery packages for air ducting and also with heat exchangers for water cooling. And that can reduce the load on your boiler. Next slide, please, Caleb. Are we on the air quality specs page?
Yes, sir.
Okay, thank you. By the way, Caleb, I'd like to thank you, I should have at the beginning, for coming to our show last year for TDEC's huge role in 2019. You guys are just amazing. So, and dealing with speakers who can't figure out how to log into a Cisco WebEx thing.
Well, and I will add, the Best Practices Expo is something that I plan on attending, for the rest of my career. It's just a great time to see new technologies, hear, success stories that these manufacturing sectors, like sort of case study type deals, like you're mentioning right now. So, it's something that I definitely would recommend, especially if you're working in the maintenance or the environmental and health side of the manufacturing sector. I think there's really great opportunity with the expo to just find ways to save money with energy and of course with compressed air, which of course equates to energy use and then monetary values. But yeah, if they let me, I plan on attending the expo no matter where it is.
Well, thank you, Caleb. You're always invited. Okay, so here's another phase 2 advanced project. And we made these because sometimes you run into folks who say, we've already optimized our compressed air system. There's so much you can do, though. These are advanced projects. Here's another one of taking a look at your compressed air dryers, understanding the dew point that you have, the level of dryness that you're drying it to. So basically, the drier the air it is, the more energy it's going to cost you. So if you have a semiconductor plant, you need that minus 40, even minus 100 F dew point. But we do run into plants all the time where a refrige dryer broke down, which is the most energy efficient type of dryer, which gives you a 38 F dew point. But it broke down for some reason. And so the plant said, to hell with it, we're going to get a desiccant dryer and go to minus 40 dew point. They didn't really need it. They just got fed up with that refrige dryer. So there is a significantly higher energy cost when you go to minus 40. So we always tell people, if you need -40, fantastic. These are great dryers. Desiccant dryers will do that for you. And there's different types, and there are heat of compression types, and they're wonderful dryers. I worked for the biggest manufacturer of them. But don't use them if you don't need to. Go with a refridge that's 38F. So know why you have the dew point you have. Here's another one. Blow molders are the best example of it. Here's a big Krone, and Seidel's the other big brand. But here's a big Seidel blow molding machine. But and they've done amazing at all those plants to optimize their systems over the past 20 years. But basically, a lesson learned from them, because most of them have already done it. In the old days, since they were doing PET containers at 515 PSI, in the old days they would have one big compressor room with high pressure air compressors providing compressed air to the whole plant at 500 PSI. And so it was being regulated down to lower pressures all across the plant. Extremely expensive. So what they've done is they've separated into two systems. The blow molding lines at 500 PSI or 400 PSI, wherever it's at, and then plant air with a separate compressed air system at 100 PSI. So at your plant, it might be that you have a 100 PSI air compressor, but you might have one application or two that only needs 35 or 10 PSI. And that's where you would separate it and use blowers for them, or boosters, is what some people call them. So at any rate, looking at subzones is the idea. Maybe you have 100 PSI plant air for 90% of your plant, but you have one application that needs 300 PSI. And that's where you can use a booster. Okay, so creating zones of pressure. Next slide. We have 4 more slides here on advanced trends, so hang in there with me. This is one from Ball, from their aluminum can plants. And it was interesting, compressed air is their #1 user of electricity, and it accounts for between 20 and 30% of total electrical use at their plants. So this is just an example of a quote from them was that compressed air audits have reduced compressed air energy costs from 50 to 40 million per year over the past 5 years. So they did a good dent in that operating cost. And here's a quote from Doug Barnt, where one of their big successes was they took their overall plant pressure from 110 PSI, 120 PSI, down to a target of 80 PSI in each plant. And they did that with this quote of, "We believe in engineering solutions into our processes to keep lowering pressure." A can printer used 125 PSI. Now we use a 2-to-1 amplifier to support the 2-inch cylinder needing that pressure. Okay, so they literally went into the pneumatic circuits on that can printer so that it could use lower pressure air at around 80. And that was part of their secret to success. Okay, next slide. All right, this kind of goes back to the Saint-Gobain example of optimizing pneumatics and OEM equipment. It's also similar to what the Ball just did, but this is a unitizer machine, right? Some people call them case erectors there on the right, and it ships with a 3-position valve, with a 2-position valve, which, as we said before, when the machine is idle, 2-position means it's either on or off. So they have it on, open, all day, even when the machine is idle. So by calling their pneumatics firm and putting in a 3-position valve, which closes it when it's idle, their idle flow was reduced from 75 CFM to 25 CFM on 20 machines. Okay, so that was a big win for them in optimizing their system, optimizing pneumatics. Next slide. And this was what was underneath that same machine, that unitizer, that KC rector. You see all the spaghetti down here. Those are all the pneumatics tubes, the pneumatic circuit, and they just start leaking, creating pressure drops. So this is a before and after picture of how they cleaned it up. They put flow meters up at that top, at that center console, and they created that best practice flow once they cleaned up the circuit. I've been to one plant that makes tires. They had 250 flow meters. They had them at every workstation, and they were all equipped to alarm if they went past a plus or minus best practice variance. It was pretty neat. It was so cool that they wouldn't let me write an article about it. All right, here's the last slide. The last example is blow-off air optimization. You can see the lady here working in the production line at a commercial bakery. This on the left is a wand coming down with a tube, and there's blow-off air, blowing off crumbs. So blow-off air is a very common misapplication of compressed air. It can be at a bakery. It can be blowing moisture off of bottles, off of packages. It can be metalworking, metal shavings being blown off. It can be at the printer where you've got pages sticking together. You don't need 100 PSI compressed air. That's 3 to 5 PSI. So you do a project where you find some blowers that are dedicated to that application, and you reduce your compressed air load by taking this application away. All right? Okay, well, that's it, folks. Thank you very much. We ask that you recommend our free publication to your colleagues. You can subscribe there, and we'd love to see you in Atlanta in October. Thank you very much, Caleb, and thank you, TDEC. You all are just amazing what you do for the state of Tennessee and energy efficiency work.
Well, thanks, Rod. So what I did is, here on the slide right now that you're seeing, you see the where you can subscribe for the Best Practices magazine. I went ahead and put that in the chat so that you can copy and paste that, or go ahead and click that and have that URL up so you can check it out for yourself. Now, we do have this next slide is actually for the Best Practices Expo contest. So this, you're glad that everyone stayed around for this, because this is where you can play for a chance to win a free full conference pass to the expo that we were talking about. Now, this is like a $675 value, and the contest is, of course, open to a wide range of people. I'm assuming that basically everyone in here would definitely benefit from being able to come to the expo. So it's very simple. All you got to do is, we've got A, B, and C right here as our answers. The question is, why should you send your team, or why should you yourself, or why should you send your team to this Best Practices 2022 Expo? What I want you to do for the answers is click in the chat box, go to send to, the drop down should just be host. So make sure you're just sending that to me so you don't give away the right answers to anybody else. Yeah, so make sure that says send to host, and then I want you to send me the answer. Do you think it is New Technology Expo with on-floor classroom? Do you think it's keynote presentations and open/plenary sessions? Or do you think it's the Daily Expo $1,000 energy treasure hunt raffle? So, it can be multiple answers. It could be just one single answer. So send those in to me, and then later this afternoon, we will take all the correct answers, throw those in a hat, and pick a winner for the free full conference pass to the Best Practices 2022 Expo and Conference. And like I said, it is something that I plan on attending. So, we'd love to see everybody there. And also, it's pretty easy to talk your bosses into letting you go to an expo, especially if you get a free pass. So send those answers in, and then once I get all of those done, or get all the correct answers, we'll put that in a raffle, and then we'll get a winner drawn. So I've got a couple of answers coming in. Ooh, I see some correct answers already. Let's see. And I'm pretty sure, like I said, I'll be there. So you definitely want to, not only do you get to learn a lot about different best practices and talk about all the new technologies and information that you might be able to bring back to your facility, but also you get to hang out with me, which I think is pretty cool.
That should be our number one reason.
Let's see. All right, I'm going to give 2 more minutes, so please make sure to send in, and don't overthink it, everyone. Rod went over this at the very beginning, and so don't overthink it. Send in your answers, and if you only get, there might be more than one answer that's correct. There might be just one answer that's correct. I don't want to give it away too much, but don't think about it too much. Just send in those replies, and then, like I said, tomorrow we will announce who is the winner of a free full conference pass.
And Caleb, I didn't mention, this was an example of what you'll learn on the compressed air energy conservation side. But we'll have leaders there in auditing chillers, the other big energy user. Also vacuum pumps. We've got some amazing people coming to talk about vacuum pumps and how to optimize their use, how to maybe switch away from liquid rings to dry pumps and reduce your water bill. And then on the safety reliability side, we've got great sessions on how to maintain your air compressors, how to maintain your dryers and your drains so that you don't have water and moisture and oil going into your food products or into your paint jobs. So the maintenance side of this is just critical because you can, as you know, you create the best system in the world, but if the drains don't work, boy, that water's just going right down into your product. So we'll have, what kind of safety standards, safe quality foods, BRC, how do you bring compressed air maintenance in compliance with your safety process if you're a food plant? So that'll be in, the reliability safety part of the conference, and equally important. And we see a ton of issues out there and lack of guidance. So that's what this conference is all about.
All right. Well, I'm going to go ahead and I'm going to go to the next slide, which tells what is the correct answer for this. So, so boom, it's actually all 3 are correct. So, if you said just 1, you said 2, you said all 3, you got that answer correct. So, all of those names, like I said, will be put into a little random name generator, and or I guess random choosing, and then tomorrow with the follow-up, which will have the recording of this webinar, the slides for your viewing pleasure, and then also announcing the winner of the free full conference pass. So Rod, thank you so much for, number one, all that you do, and it's been such a pleasure getting to work with you throughout the years, and I'm excited for the future. I'm excited to head down to Atlanta towards the end of the year.
Well, it's my pleasure, Caleb, and it's organizations like yours that give us our tackling fuel and our motivation, and for all the great things you do for energy conservation in the state of Tennessee. So we love working with you and can't wait to see you down in Atlanta.
All right, well, everyone have a great rest of the week, and be on the lookout for that follow-up email.